Okay, today's plan, we're going to finish the momentum part, and then the rest of the time, it's not going to take long. The rest of the time, we're going to explain your homework. So, for the momentum part, we still have some leftovers. Please be aware that momentum will be covered in period quiz. Okay, I think we were somewhere. Did we talk about this here?
Yes.
Did we talk about this and this here? Did we talk about this here?
有的
讲过了是吧？What about here? The sand here?
Yes.
Sand 讲过了是吧？
脚车，然后
这里呢？
水，
这里还没有讲是吧？It's the same example as the sand one, so we're just gonna skip that. Those are more examples. I will provide these examples to you. Okay, here different types of collision. That's something we didn't learn in MIT. In MIT, we just learned collision. But in DP, we can dive into more subcategories, such as elastic collision, inelastic collision, and perfectly inelastic collision. Alright. So this is still an example for the airplane, but we don't care. We can just go to the next slide. So here, we're going to introduce you elastic collision and inelastic collision. It will involve part of the energy part, okay, part of the A3, but no worries. You already learned energy in MIT, and the things that we know about energy from MIT is already enough for this part, so don't you worry. So for elastic collision, in this collision there is no energy loss, or kinetic energy is conserved. It does not change. Thus, the final kinetic energy is equal to its initial kinetic energy. Let's do an example here. So two billiard balls colliding in a such way that the speeds of the ball in a system remain unchanged. And the red ball has the same speed as the white ball. And here, both balls have the same speed, both before and after, right? The speed itself does not change. So in those both situations, they are elastic collision. Do you guys still remember where I demonstrated using two golf balls, one collide each other, right? One moving, another stay at rest, and then when they collide, this moves, this stays rest, right? That is an example of elastic collision. So for inelastic collision, kinetic energy is not conserved. So there's going to be energy lost during the inelastic collision, right? The final kinetic energy is not going to equal to the initial, and it's going to be smaller. Okay? So examples would be a baseball and a hot wall colliding in a such way that the speed of the ball changes. It changes like it's moving. It's moving slower. So if I do this demo to you where I have a tennis ball, I drop it, it collides with the ground. You see, this is definitely an inelastic collision, because if there's no kinetic energy loss, then it was supposed to bounce back to the same height, right? But apparently, during the collision, there is kinetic energy loss, and you see a lot of, I think more than half of the energy is lost, right? It's not reaching not even the half of the initial height. So now, and we have another thing called perfectly or completely inelastic collision. where the kinetic energy loss is the greatest. Okay, the kinetic energy loss is the greatest, and it's always stick together and end up being sharing the same velocity. So if we have, let's say, two balls colliding with each other, right? And if they are sticky, when they collide, they move as one. Then this is a completely or perfectly inelastic collision. And in this scenario, energy loss is the greatest. Energy loss is the greatest. Okay. So an example would be two objects colliding and stick together. So we have those two. And because of this, maybe it's a magnet, maybe it's a sticky thing that keeps them stick together. Whatever, as long as after the collision, they stick together and move as a whole, then this is a completely or perfectly inelastic collision. And in this case, kinetic energy loss is the greatest. Kinetic energy loss is the greatest. Okay. So the train cars change and move as a body, as one body. Or two cars collide and then they stop at the same spot, right? 我们还是听一下这个声效。This is also an perfectly or completely inelastic collision because after the collision, both the police car and the whatever this car is moving together in this direction. All right. So for explosion is similar to a completely inelastic collision in that the bodies are originally stuck together. It's just one way, like you reverse it, right? You can think of a collision as, you can think of explosion as if you reverse the explosion. It's all pieces of the bomb coming together and then stick together, right? So that's the reason why an explosion is a completely or perfectly inelastic collision. You can think of it like that. So which means in an explosion, kinetic energy change is the greatest, right? Before the bomb is stationary, after all parts are moving into all different directions. So before there's zero kinetic energy, after explosion there's a lot of kinetic energy, right? Okay. All right. So this is an example. All right. Original at rest, but suddenly separate into two pieces. I like the demo yesterday we have, so I'm going to do this one more time. I have two magnets here. If I before I was forcing them together, they're not moving at all. I was using my force, forcing them together. So there's no kinetic energy at all. But then if I release, due to light pulse repel, right, they just suddenly split into two pieces. This process can also be think of as an inelastic collision. A completely or perfectly inelastic collision. Well, but it's not exactly the case because when I remove, I should remove both of them, right? I cannot hold one of them. So previous demonstration, I was holding one of them. That is cheating, right? When you release, you should release both of them. So you see both of them is pushing each other from both directions. Okay. So, or like a piece of ice broken into two by a hammer stroke. You use a hammer stroke it and it break. Or in this case, a bullet leaving a gun, right? The gun will move backwards, the bullet will move forward. Alright. So qualitatively analyzing the inelastic collision. First of all, since it's still collision, right? Momentum is conserved, but it's inelastic, which means energy is not conserved, right? Kinetic energy is not conserved, but momentum is conserved. So let's do this one here, right? I'll give you 3 minutes and then work on this example. I'm gonna ask a student to share with us her answer. I think this is also even solvable for MIP, right? Alright, follow the steps that in MYP I taught you. Alright. First, you find the total momentum before. Second, momentum should be conserved. So total momentum after is equal to total momentum before. And then you can solve the final velocity. The most tricky part in DP is the direction. Because velocity and momentum are vectors, right? Maybe there is a change in direction. You should be super careful about. By the way, our periodic quiz will be on C401, the test room, the IB test room. 在4楼啊。C401，就这里直接上去。Okay. Ashley, how would you solve it?
750 times 10.
What's your step 1? Mm-hmm.
Mass times velocity.
Mass times velocity will give you. Always find the total momentum before collision, right? So total momentum equals to.
Mass times velocity. And then he 750 times 10 plus 7 plus 750.
Then you should mark it correct because you have 2 objects, right? Okay, so you get
Uh, 10,000, 11,250.
so total momentum after should also equal to this, right? Or I'll just use after. PT prime means after, should also equal to 11,250. Is this correct? Everybody got 11,250? Kilogram meter per second. Then they hitch together. How do you find their final speed?
750 times 3
And?
divided by
So V equal to how do you find the final speed V?
oh, 10 minus
Oh, 10 minus 5 is the final speed.
no, I did
Which part you're not so sure about?
after part.
The after part, you already figured out this. Momentum after, right? Total momentum after. What happens after they collide? They stick together, so the total mass after is, do they share the same velocity after collision? Right? So how do you calculate total momentum after collision? It should be
Divided by 15.
total mass times total velocity, which is the final velocity because they're moving together at the same velocity, right? So V total should equal to PT prime over M total, which is 11,250 divided by 750 times 2, which gives you 1,500. So final answer is 7.5. Okay? It's not a difficult one. Even my grade 9 after learning the collision should be able to solve this. So it's not a difficult one. Okay? It's just a review, but we will have difficult one. Find the change in kinetic energy. Well, you know the previous velocity, you know the after velocity, 77.5. You should be working this one pretty easily. I don't ask you to calculate, I'll just ask your thought. Alice, how would you solve it? Let's work it backwards. Reverse it. So we're finding the change in velocity, a change in kinetic energy. Change in kinetic energy equal to what?
Perform.
Final kinetic energy minus initial kinetic energy. How do we find the final kinetic energy? Are you Alice? M is what M? Total mass. What is V? 7.5 that you just calculated, right? So M here is total mass 1,500 and then 7.5 squared, right? That's your final. What about initial? How do we calculate this? Exactly. And then you minus them to find the change, right? which you get negative 4,700 joules, right? Negative 4,700 joules. So there is energy lost, right? Kinetic energy is lost. Okay. Now, determine the type of collision. There's energy loss, so it must be inelastic collision. But if you give me inelastic collision, you will get half of the points minus. Why? It's a completely inelastic collision. Why? Because they stick together after the collision. So, first of all, this is inelastic collision because there's energy loss. Kinetic energy is not conserved. Second of all, because they move as one after collision. It's completely or perfectly inelastic collision. Now, was mechanical energy conserved? Why? Because kinetic energy is not conserved. So mechanical energy is also not conserved. What does mechanical energy composed of? Mechanical energy consists of kinetic and just gravitational? Potential energy. Potential energy could be gravitational potential energy, GPE, elastic potential energy, EPE, even electric potential energy. Alright? Okay. Oh, wait. Only those two. Sorry, because it's mechanical energy. Alright, so mechanical energy is not conserved because kinetic energy is not conserved and there is no change in GPE. Alright. Two trains, blah blah blah. Is total energy conserved? Is total energy conserved? Also no. Again, here the total energy is just kinetic energy because there is no changing height. They are on the ground, right? There is no elastic potential energy between them. So since kinetic energy changes, energy also changes, right? The loss of 4,700 kinetic energy is converted into heat and sound, right? It's wasted as heat and sound. Questions? Okay. Alright. So here we have more example questions. We're just gonna do one. It's not gonna be very difficult. Actually, one more, yes. Just this one, because this is interesting. Now, let's look at this one. Suppose a 0.020 kg bullet traveling horizontally at 300 meters per second. Oh, by the way, why is there a dot here? So it means this has 3 significant figures. This is a very precise number. If it just this, then how many significant figures does it have? One significant figure. Okay? Strikes 4.0 block of wood resting on a wood floor. How fast is the block bullet combo moving immediately after collision? 3 minutes. 这样的吗？这种思考，A2 下的
총알을 빼야지 들어갔잖아.
S2要考的 H2 都要考，H2还有额外要单独考的。Okay, so how fast is this block bully combo moving immediately after collision? Let's say Jessica, 1.4 meter per second, 1.49. Why do we only save two significant figures here? Because we have here 0.20, which have two significant. 谁说的 three? Leading zero 算吗 ？Leading zero 不是。Two significant figure. 300 have three significant figure. 4.0 have two significant figure. Whenever you solve the problem, the final answer should always save to the least amount of significant figures. So 4.19 should round it to, 1.49 should round it to 1.5. Okay, now, again, similarly, but slide 6 meters before coming to a stop. Find the friction F between the block and the floor. This could be a little bit more challenging now. Velocity final, we find it is 1.5 meter per second. I'll write it down here. I'll give you 3 minutes to think about it. Discuss, you can discuss with each other. How do you find this friction F between the block and the floor? You can tell me, okay? So A1, A2, fire. Let me know what are the stuff that you want me to explain. Let's look at A1 first then. A1, 第几页？第几题？马上 share 一下 screen。第13页的第26题。
12页的23。
那我们先看23题吧。So let's look at 23. A raindrop falling from rest at t time equal to 0 reaches terminal velocity. Which graph best represents how the speed varies with time t? So raindrop falling from rest, so it should start from 0, right? Which means it should start from the origin. All of them start from origin. Okay. Reaches terminal velocity. So when a rain drops, what would happen to its velocity? Will it drop faster and faster? Will it drop faster and faster? No. Why? Okay. If you guys forgot or you don't know, let's review some of the E9 content. 这个应该是 Chapter 3的。我们是哪里学的 terminal velocity？ 哦，是这儿。Okay, let's look at here. What is terminal velocity? When a skydiver jumps out of the plane, why does it eventually stop accelerating? So, stage 1, right? A skydiver just jumped out of the plane. The only force acting on him downward is just gravity. Because it's not falling yet. There is no relative motion between him and the air. So there's no air resistance. Right? Air resistance basically is moving air, right? You're moving through air, you feel the wing, right? You feel the wing, that's air resistance, right? That's air resistance. So if you're not moving at all, there's no air resistance, right? Okay. As he falls under the gravity, he will fall faster and faster. As he falls faster and faster, what happens to air resistance? It will increase, which makes sense, right? If you just walk slowly, you barely feel the wing, right? If you're starting to run, you feel the wing more powerful. If you're in a car, driving on the highway, you stick out your hand, the wind is very strong, right? You can feel the push. So the faster you go, the greater the air resistance. Does that make sense? Right? Okay, so during this time, this guy, skydiver, will keep falling faster and faster. And in the meantime, air resistance would also increase, right? Can air resistance infinitely increase to infinity? No, there's a point where air resistance will matches the gravity. Then what happened to the velocity of the skydiver? It will fall at a constant velocity, which is the terminal velocity. If velocity no longer accelerating, no longer getting larger, will air resistance keep getting larger? No. So eventually the force of air resistance balances out the force of gravity. And at this point, skydiver accelerates and reaches terminal velocity. Right? So if you plot a graph like that, what happens at point A? It starts to fall. What happens at point B? Reaches terminal velocity. What happens at C? Open up a parachute so that its velocity speed decreases drastically. Right? And D reaches new terminal velocity. What happens at E? Landing. Right? Okay. So let's come back. So in this case, similarly to a raindrop is similar to a free falling of a skydiver, eventually reaches terminal velocity. So which graph? B. Okay. And then we have 25 or 26? 26. A ball initially at rest is shot from in the air from a great height. Air resistance is not negligible. Which of the following graphs best show the variation of the time to the acceleration of the ball? Isn't it the same? Right? So we know that as it falls, initially it's just no air resistance. It will fall on the gravity. But as it gets fall faster and faster, there's gonna be F air increasing, right? Eventually balancing out. Eventually F air is gonna equal to W, right? So which means acceleration at the very beginning, when there's pure gravity, acceleration A equal to G, right? As this getting air resistance increasing, it will balance out weight little by little. So net force is decreasing, right? If net force decreasing, acceleration would also decreasing. Acceleration decrease, so smaller than G. Eventually, when there's no net force at all, acceleration is 0. So what is the acceleration time graph? Acceleration starts from g and eventually is 0. So it should be something decreasing, right? So this is not possible. Not increasing, not this. Only C and D. Now the question is it gonna be a linear change?
No.
No. Air resistance when you are falling faster and faster, air resistance is actually proportional to the square of the speed square. So it's not going to be a linear change. So it should C. Okay. Any other questions? 38, 28. Two balls of different mass are dropped from the top of the tall building, one after another. The distance between the ball, okay? Two balls, different mass, dropped from the top of the tall building, one after another. The distance between the balls. So let's draw a speed time graph. We dropped the first ball, right? Okay. If we ignore air resistance, then it should be a straight line, right? Okay. And this is time. One after another. That means after some certain time t pass by, you drop the second ball, right? If we ignore air resistance, how can we draw the second ball? Is it correct?
Parallel.
Why does it need to be parallel?
Because the force is also gravity.
Does mass matter here if in free fall?
No.
Mass does not affect the acceleration due to free fall, right? Now, what is the gradient in speed time graph? Acceleration. So if acceleration of different mass is the same, then gradient for both graphs should be the same, right? So this black line is wrong. It should be parallel to the second line, right? Okay, it's asking the distance between the balls. What represents distance in speed time graph? Area. Okay, so start from here, right? This, before the second ball is dropped, the first ball has already moved this much, right? Okay, let's compare. When it comes to here, this much here. So the distance moved by the first ball is this much, right? What about the second ball? This much, right? So what about the distance change between them? It's this area, right?
Yes.
Compared to initially, this area is, and if you keep going, the time keeps falling, this area would keep adding. So the distance between them is going to be increasing, right? Increase with time. Get it?
但是还是 depend on initial velocity. The distance between 如果 initial 的话跟上的话那个 time，它当时那个它的 distance
Drop. Drop 什么意思啊 ？Initial velocity 就是 zero 呀，对吧？这题的答案不是选 A 吗？这题答案是我给你的答案不是 A 吗？什么叫 drop 呀？
这样也算 drop。
这个叫 throw。这个叫 drop。这个叫 throw。Okay. All right. Anything else? 29. The graph shows how the velocity of a particle varies with time. Which of the following graph correctly shows the acceleration? What is acceleration in velocity time graph? Is gradient changing? It's gradient changing. Then
CD big one, so C.
then A, B directly cancel out. Now is gradient positive or negative? Positive, so choose C. Anything else?
No.
32.具体哪个问题 Okay, 32. Right here. Stage 1. Speed attained at the end of the stage 1. Accelerate. Starting from rest. So it's 0 to this and 44 to this. Okay. Average acceleration easy. Average net force required in stage 2. Average net force. How do we calculate net force?
Change of V over T.
Right? Okay, so you need to figure out stage 2's average acceleration. So stage 2, how do we calculate acceleration? Changing
Delta V over T.
delta V over delta T. Delta V is 280 minus 44. Changing time is 12 minus 4. So A equals 29.5. And then net force is just this times mass, which is 1.1, times 10 to the power of 4, which you get. What's the final answer? 3.24 times 10 to the power of 5. Anything else? Question C. Also 32. Total distance traveled by the car in 12 seconds. In 12 seconds. So we separate it into 2 stages, right? Stage 1 and stage 2. We calculate the average acceleration for stage 1. We have A1. We calculate average acceleration of A2. Then you just apply Subak twice, right? You apply Subak twice to find the displacement and then add them up together. 这样吗？对啊 different acceleration 嘛。So you need to separate it into 2 stages. 你是怎么做的？看不懂。OK， 我做一遍吧，好吧。So stage 1的 acceleration 算出来是多少的 ？Stage 2我们刚算出来是29.5，对吧 ？A1 呢？44除以4， 11，对吧 ？So for stage 1, we know SUVAT. We're looking for S1. So U is 0. Final is 44. A is 11. Time is 4. 用一个最简单的吧，哪个最简单 ？S equal to V square minus U square over 2A. 那就是44 square minus 0 over 2 times 11. 对吧？44乘以44除以2乘以11， 4、2、88米。That's the first stage， 对吧 ？Second stage, again you apply SUVAT. SU 换一个颜色吧。SUVAT S2. So U is 44. Final is 280. A is 29.5. Time is 8. So again, use the 最简单的，那我还是用一样的 s equal to v square minus 不要，它这样子算，那我就用 s equal to ut plus 1/2 at square. Then we're gonna have 44 times a plus 1/2 29.5 times a squared. What's the final answer? 1,296. And then you plus 88, so you get 1,384. Is that the final correct answer? Is that the final correct answer? 像你这种2分考试只能得一个结果分，为什么？老师拿到第一眼看不懂，你的公式在哪里，对吧？你怎么去解的？你这个解题思路就很不清晰。如果是3分题，你也只能拿1分。When you solve the problem, you have to make sure that the examiner understands your thoughts. So instead of directly just put numbers there, you need to show the equation so that I know how you solved it, right? I know that you understand it. Otherwise, you can just, if you got answer correct, you only get 1 point for the final answer. If you got the final answer wrong, you got nothing, right? You got nothing. Any other questions to talk about? A1 还有吗？没有的话，我们看 A2。A1 没有了是吧？好，我们看 A2。19。
所以就19而已，13，所以就是3。
第几页？10页的第，先看一下整道题。State and explain the magnitude of the friction acting on the ball at t equal to t2. T equal to t2 的时候，它的 velocity 怎么了？No change in velocity, so what is the acceleration?
Equals
Zero acceleration. If acceleration is 0, what about net force? Net force equal to ma is also 0. So that means all the forces are balanced. So when it's at time t, its weight is being balanced by the friction, right? So friction is equal to weight, equal to mg. So state and explain 2 marks. State F equal to W equal to mg. Explain why? Because at T2, A is 0, F net is 0, equal to W minus F. So F equal to W. One check mark represents 1 point. Any other questions?
Question 20.
Question 20.
CII.
CII. CII 不用管，不会考。Don't test you. Don't test you. It's B1. It's from B1. Anything else? 多少题 Question 20. Question A. State without any calculation how the graph could be used to determine the distance fallen. What is this graph? What represents the distance traveled in velocity time graph?
Area.
Area under the graph. So that's all. stay without any calculation. So area under the graph. Any other questions? Hmm? 20B. B in the space below. B2. Oh. Use the graph opposite to show that the acceleration of the ball at 2.0 is approximately 4. So it needs to use the graph here at time equal to 2, right? The slope at this point is the acceleration. Alright, so you need to find out the slope at this point, or the tangent, the slope, the tangent at this point. So, 我把它放大一点。So if we pick this point and we draw its tangent, it's about this much. So its gradient can be calculated from this changing here divided by changing here. So that's about 15 minus 13 over time is about 这里到这里 time is about this much. So 这里是 1, 0.4 对吧 0.4. So you get 2 divided by 0.4, which is 20 over 4, roughly give you 5 meter per second squared. Okay, it will end up giving you a range. So let me check the mark scheme. The mark scheme says range. It's in a range of 这第几题来着？20题的第 B2小问。So it says in a range of 3.6 to 4.4. 哦，那我这个 range 有点，我这个有点大了。重新再来看一下。So at 2, here maybe 这里找一个，这里再找一点，这一点其实好像还没有到13，对吧？13点多，那就15减去13.4或者13.3除以还是0.4，对吧？那你得到的是1.7除以0.4，算出来是多少？4.25，那在4.4的 range 里面，对吧 ？OK, that's how you solve it. 还有哪些题？我可以把答案给你们看一看啊。这是20题的答案要看啊，19题的答案。自己看吧。Power, you don't have to care about it. Yeah, power don't care. We won't test your power. 看完了吗？
说谁的秘密？亚飞的。
看完了吗？Okay, let's move on to the next. When you draw the diagram, when in an exam, whenever you are asked to draw a forces diagram, you must use pencil. If you use pen, points minus.看完了吗？这儿
No gravity on the weight. 그냥 뭐 봐, 에어리스 쓰는 그레이디 잘하는 거.
看完了吗？
아이, 좀 이래.